we will continue to find out moment of inertia for some special case. Here, our special case is we have to find out moment of inertia of a thin uniform rod. Suppose this is our thin uniform rod AB, and for that we have two cases. This is case 1 and this is case 2, and the length of this rod is L. The length of this rod is L. So first of all, we have to find out the moment of inertia of a thin uniform rod about an axis, and this axis is about through its center and perpendicular to its length. So we have to find out when the axis is through its center. This is the center and perpendicular to its length. Perpendicular to its length. So this PQ is the axis we will consider, which is perpendicular to the length AB, and it is going through the center of this uniform rod. So here two cases, it goes center, PQ is in center and it is perpendicular to AB. For that case, our moment of inertia I will be equals to the, we only consider the value of what will be the value of this, that is equals to the I is equals to the m by 12 ml square by 12 m l square by 12, and the radius of gyration will be k equals to 1 by l by, not 1, it will be l by 2 root 3, where m is the mass of this rod, m equals to mass of this rod, and L equals to the length of this rod. So we know we calculate the formula for the first case. Now coming to the second case, the second case says that while our axis will be changed, it says that moment of inertia of a thin uniform rod about an axis through the one end of the rod and perpendicular to its length. So now the axis will be one end of this rod. Suppose this is the end of this rod, one end of this rod, RS, and perpendicular to this axis. Here our RS is at the end, and perpendicular to AB. At that case, our moment of inertia I will be I is equals to 1 by 3 ml square. So we can say that ml square by 3, and the radius of the gyration k will be k equals to the L by root 3. L by root 3. So this is the two cases for calculating moment of inertia of a thin uniform rod, and there we consider two axes. One is going through the center and perpendicular to the length, and another is at the end of the at the end of the rod and perpendicular to the length. Now the second one is we have to find out moment of inertia of a rectangular lamina. So suppose this is our rectangular lamina. This is our rectangular lamina. Which is A, B, C, D. Now, first of all, we will consider the second case first. Then we will see what is the first case. Now first consider the second case. Second case says that moment of inertia of a rectangular lamina about an axis, and why the axis is situated, so its center and parallel to one of its sides. So our axis is through its center, as this is the center of this AB, through its center, and and parallel to the one. So this axis, suppose we take this axis as PQ. PQ is at the center of lamina and parallel to BD or AB. BD or AB. So we have to find out the second case. So what will be the moment of inertia of this plate as we consider the parallel axis is ABD and AC? Then we, so at that case we will consider the length of this section is L. So here M equals to the mass of the lamina, and what will be the length? L equals to the AB or CD. We not take the length AC or BD. If we take this length if we take this length AC or BD, the axis will be at the width position. As we take this axis at the length position, so we will take the length of AB. At that case, at the case 2, so at that case the moment of inertia I will be equals to the I is equals to the ml square by 12, and radius of gyration k will be equals to k equals to 1 by L by 2 root 3, L by 2 root 3, and it is actually equals to the our actually it is equals to the first case of our thin rod, uniform thin rod, where the axis is at the center of this center of its center of its length, and it is perpendicular to its length. So our case 2 is equals to the is equal to the first case of our uniform thin rod. Now coming to the first one. In case 1, what is case 1 says? The case 1 says that this axis, the axis is perpendicular to its length, perpendicular to its center of mass. So our axis will be perpendicular to its center of mass. So as this is 3D view, we will redraw this lamina. Suppose we draw this lamina. This is our rectangular lamina, and the center of this mass is this point P. The point P is the center of our mass. So when we draw a perpendicular axis to the center of the mass, this perpendicular axis will be this one, this RS. Here RS is the center going through perpendicular to the center of mass. At that case, what will be our moment of inertia? The moment of inertia I is equals to the m by 12 L square plus B square, where L is the length of this rectangle and B is the width of this rectangle. At that case, width will be BC and CD. Yeah, BC and AD. So that is the moment of inertia for the case 1. And what will be the moment of inertia or radius of gyration of this first case? The moment of inertia of this first case will be 1 by 2, or we can say that half of root over L square plus B square by 3. So this is the Second case, this is the first case of our moment of inertia of a rectangular lamina, where the axis is perpendicular to its center of its mass. Now, the last one, we will see this last special case. This special case says that we have to find out moment of inertia of a circular disc, of a circular disc about an axis perpendicular to its plane passing through the center. So, let me draw this disc at that manner in our xy plane, and this and that will be our z plane, and this is the center of this disc, and the radius of this disc is r, and our, it says that our axis is perpendicular to its plane passing through the center. So our axis is passing through the center. This is our axis, this is our x o x prime axis. At that case, what will be the moment of inertia? At that case, our moment of inertia equals to m r square by 2. And what will be the radius of gyration? The radius of gyration k equals to r by root 2. So this is two case. This is another case of a circular disc. We have to only remember the formulas for this circular for this moment of inertia and radius of gyration for these special cases. Just we have to remember this formula. There are some derivation. Please do to yourself and find out how these derivations are happen, how we find out the formula of I and k for these special cases. Please understand and remember all of these special cases, and try to remember the moment of inertia and radius of gyration for all of these special cases. That's all for today's video. Hope you like this video. Do subscribe to our channel. Thank you.